Good evening, everyone. You are welcome to today's edition. Let's say it starts of a new week. Since in the last session on Saturday, we started discussion on chi-square, and we have gone through Pearson chi-square, likelihood ratio chi-square, the Yates-corrected chi-square, Fisher exact test, McNemar chi-square, and chi-square for goodness of fit. And I think the last one we have not discussed is McNemar-Bowker Chi-square. So we want to go straight. We also discuss chi-square for trend. So I don't know if anybody has questions. Yeah, I can see I see some new people are just joining, and but I don't think any question now because we have discussed a lot. So we want to quickly wrap up the chi-square with a discussion on McNemar-Bowker Chi-square. And it looked easy. It appeared to be the most complex somehow when it comes to chi-square. As I told us before, chi-square is more complex than t-test. T-test is simpler, but because somehow when you do statistics, sometimes the only test statistic they teach you is chi-square. But the reason is that chi-square is a family of, apart from the fact that the distribution is a family of distribution, which the shape depends on the degree of freedom. Apart from that, there is also type for each family. There are also type. So it can be, like this person, all those ones that I mentioned, they're just type. We still have some that don't even use normally, but in some other statistics, like for word statistic, Kukawalis, they are still chi-square. Mantin-Hezin, chi-square for stratified analysis. So, but let's quickly wrap up the chi-square discussion by looking at McNemar-Bowker. Just 1 minute. Yes, thank you. You see, if you remember when we discussed McNemar chi-square, it says used for to compare pair categorical data. Categorical paired. Categorical means that it's not numerical, it's proportion you are comparing. You are comparing percentage. And for McNemar, the category of outcome must be true. That is, yes, no, there, not there. Hypertensive, not hypertensive. That was the example we used. Hypertensive, not hypertensive. Only two categories. But and we also say, because when we say McNemar is for peer observation. Peer means that you make your observation on a group of people. You come back, that's first group. I've already told you, group in statistics and research does not necessarily mean group of participants or group of subjects. It means group of the data you have. So when the group of the data is that is the data is from separate independent group like male, females, urban, rural, that's independent group. But if the data you collected, the two group of data is from the same group on two occasions, like before and after, like this example we use for McNemar, we talk about somebody measuring the blood pressure in the community and now categorize people either to whether they are hypertensive or not. So all the people that are involved, they eventually classify them into hypertensive or non-hypertensive. So you have two groups, two possible outcomes. That is the same group, two possible outcomes. You collect the data, you classify that hypertensive or non-hypertensive. Later, you carry out your intervention on them. That is, you give your instruction, you teach them exercise, many things that you help to improve the hypertension status. You now come back after some months and now use the same measurement of blood pressure and now classify them to the same group. If Eunice was there, Eunice must be there. If there are 300, all the 300 must be the same group. You come back to measure their blood pressure and classify into hypertensive, non-hypertensive. Are you see now? Because you now have two group of data, before and after. The one you did before intervention is the first one. The one you measured after intervention is the second one. But since the data is from the same data set, are from the same group, the same persons, so it's peer group. That's what you use McNemar for. If we are dealing with quantitative variable that is not categorical, that's what we use peer t-test for. Now, the same thing we are looking at McNemar-Bowker. What makes McNemar-Bowker different from McNemar is that in McNemar, there are only two possible outcomes. Possible outcome of the variable: hypertensive, not hypertensive. But in McNemar-Bowker, when you have more than two, for example, the example we're going to be using here now is socioeconomic status: upper, middle, lower. So when you assess people, you can say this one is the upper class, this one middle class, this one lower class. So in that situation now, to say somebody is in upper, middle, or lower socioeconomic status is categorical. It's not numeric, it's not number. So number one is categorical. And the category are three. That is what we use. It can be 4, it can be 5. But in McNemar, it's only 2 categories. Let's say we say upper, lower. That would be 2 categories. That would be for McNemar. Since we have 3, upper, middle, lower, that is McNemar-Bowker. They may have 4, it depends. Maybe up to 4. But the example we are using here is 3. Just for you to understand. All the features, everything we did in McNemar will be done here. But because there are 3, there are some complexity that are involved. For example, now, if I ask you, how many times, it's pair. How many ways can you pair? Yes or no? Hypertensive A or B, let's say 2 groups of outcome, male, female. Yes or no? Hypertensive, no hypertensive. How many ways will you be able to pair? It's only once, because there are 2. A, B, you are pairing them. A, B. You can only pair them twice. But if there are 3 categories, like when we say upper, middle, lower, we can call A, B, C. In how many ways can you pair? When you say pair, it means that you are grouping them to 2, 2, 2. So this is what we call combination now. So you remember permutation and combination. So two groups can be combined in only one way. Can be paired in only one way. But 3 can be paired in 3 ways. Can you see now? Can be paired in 3 ways. And when we are talking of 5, you will see that it will be paired in a way that is different. If let's say are talking of maybe 10 way, 4, 6 way. And that's what with this table was just telling us. Different way you can combine the group. If you look at it now, you see the first column on this table I'm showing. Number of categories, K. Number of category. The first one, you cannot say you are pairing only one category now. If it's not even a variable. anything that is only one category is not available. For example, now you are dealing with women alone, maybe in the antenatal clinic. You talk about sex. Sex is not available in the sense that all of them are female. So you cannot pair. So when we talk about pairing, we are talking about 2, 3, 4, 5. That's why you see number of categories start with 2. So that 2 now is just representing that one we use for McNemar, because there are 2 categories. Then number of cells, if you cross-tabulate the category, remember, it gives you 4 cells. You remember when we started this chi-square, the simplest one is 2 by 2 table. When we say male, female, employer, non-employer. So male, female, employer, non-employer. So it gives you 4 cells. The same thing when you say hypertensive before, yes or no, hypertensive after, yes or no. When you cross-tabulate, as you saw the other time, it gives you 4 cells. When you now say number of concordance, you remember what I mean by concordance that time. You know, you remember the cell, the type of cells we have. Okay, maybe I just talk about. Let me quickly go back to that one so that number of concordance, maybe because I didn't really hammer it too much or need too much. What we mean by concordance is here. Look at this table we use for McNemar. You see, when we say hypertensive, look at the one below. Hypertensive before, yes or no. That's along the row. Along the column, hypertensive after, yes or no. So there are 4 cells now. The one that has 8, the one that has 52, the one that has 32, the one that has 108. So if we use normally in 2 by 2 table, look at the table up. We call it A, B, C, D. That's the way, A, B, C, D. A is 8 here. B is 52. C is 32. And D is 108. All those other ones in blue, all those other cells, they are the addition, totals. They are the totals. So they are not, when we are talking about number of cells, is the one in the middle is not the total you are looking at. So there are 4 cells. This is 2 by 2 table. There are 4 cells. Now, the concordance here is the A and D, or 8 and 108. The reason means that 8 people were hypertensive before, they were still hypertensive after. It's the same thing. That is, they didn't change. If you look at 108, were not hypertensive before, still after they were not hypertensive. So that is why A and D, the one color in white up, are the concordant. But discordant are the one that change. So if you look at the table below, 52 were hypertensive before and became non-hypertensive after. Why? So it has changed. Then 32 were not hypertensive before, they became hypertensive after. So we said, 52 moved from hypertensive to non-hypertensive, 32 moved from non-hypertensive to hypertensive. They are the discordant. And in McNemar and McNemar-Bowker, it's the discordant you are looking at. It's the discordant you are actually using to calculate. So at least you have understood the meaning of discordance and concordance. Let's go back to our McNemar-Bowker now. Yes, the table. So when you say number of discordance cells, you see for 2 by 2 table, that's for the McNemar, is 2. Number of discordant is 2. Discordance cell is 2. Number of pair of discordant cell, that's what you are interested in. Pair of discordant cell is 1. You remember that the one that has 32 and 52 is a pair. When we say pair, that is, there must be 2. And the 2 combined, standing together mean pair. So that first row now explain the McNemar for us. Just McNemar. So you may forget about this other last column. Is for some mathematics. I just put a discover later. You don't even need it to explain for people to understand. It's just the combination, the way you do combination. In how many ways can you combine so group? So that's the way we work it. Just for you to see how we we calculated the number of pair of discordant cell. If you look at it, number of pair of discordant cell, that last table column describe how it was you can calculate. But that's for calculation. In real life, when you see the picture, you draw the table, you'll be able to even count it. No, you know, whatever you see, formula, table, sometimes in real life, it's just a model of the real life situation. So now let's move to second row now, which is the example we are using today is three category: upper, middle, socioeconomic class. So when you have three category now, number of category, number of cell will be 3 times 3, which is 9. K times K, that is 9. So let me just give you, look at the table, example of the table now. Socioeconomic class before, that's along the row. Socioeconomic class after, along the column. You see, before is you have upper, middle, lower. After, you have upper, middle, lower. So the green cell now are the number of cells. How many? 9. 3 times 3, 9. Now, if we say number of concordant cells, so if you look at it now, how many of the cells are concordant? If I ask you now, you may not be able to say it, but it's very simple. They have in the table also that make it easier. Look at it. You see number of concordant cells. It's the same thing I put here. So when we say number of concordant cells, now you see the white along the diagonal. That's the concordant. So 3 group, 3 concordant cells. If we even look at this table, you see that the number of concordant cells is equal to the number of the category. If you look at it, first column and the third column, the number of concordant cells, if there are 3 categories of the outcome of the variable you are dealing with, 3 category possible outcome, possible values. So the number of concordant cells will be 3 also. Look at it. So you can see 6, which is upper. Concordant means that it was upper before, upper after. 36, middle before, middle after. 93, lower before, lower after. Can you see along the diagonal, that ruler white, that's number of concordant cells. The number of discordant cells, that is what maybe, is unless, how can you calculate it from here? You see, for row 2, number of category 3, you see that there are 6. You will see that consistently, then for 4, there are 12. You will not say that is double it. Can you see? For 5, there are 20. For 6, there are 30. So it just all those are just to let you know those are from down to know the way it goes. We are not dealing, because the more the number of cells or category, the more complex. But of course, all those things, when you use statistical package to analyze it, it gives you. But just for you to know the logic behind it. So for our own now, we are looking at 3 categories and number of discordant cells are 6. Look at them. So the first, and they are arranged in pair, 7 and 14. Can you see? So like for 14 now, 14 is upper before, middle, late after. 7 is middle before, upper after. Can you see? So is that between interchange between upper and middle. So that red, the one in red, 7 and 14, is interchange between upper and middle class. The green is 15 and 22. Is interchange between lower and lower before, and upper after. Sorry, upper before and lower after. Between upper and lower. Upper 15, upper before, lower after. 22 is lower before, upper after. Can you see? Now, the last pair, 57 and 50. 57 is middle before, but lower after. 50 is lower before, middle after. Can you see now? Those are so the number of cells that are discordant are 6. Of course, they are arranged in pairs. So it shows you that the number of cells that are discordant can never be odd number. It has to be even because they appear in pairs. I don't know if there's any question before we move further. Because you need to understand the logic behind it. Though it's the same thing with McNemar. It's only this one I just explained. That's all. Everything follow is the way you did McNemar. So if there any question, let me know. You can raise your hand or you can chat. Now, we have tracked the number of discordant. Then number of pair of discordant, of course, no, it will be half of it now. So if the number of discordant is 6, number of pair will be 3. And that's the last when we do our combination, that's what we have. Number of pair of discordant cell is 3. So that's what we just explained now. Number of pair is 3. So I think we'll move further there because all these things, the total, if you look at it, nothing concerns the total bed, of course, you have to ensure that all the total up. Now, if you remember, what we have just you've seen, we put in on the table, 3 by 3 table, 9 cells. They are all these values, they are observed value. That is the value you got when you do your study. So in this situation now, if you look at this question in data, it's talking about the socioeconomic class of people before and after, immediately after COVID-19 pandemic. So this is, if you look at it, you see that this group of people, we have 30, usually there are 300 people. Before COVID-19 pandemic, we have 35 that are in upper. We have 100 that are in what do I call it? 100 that are in what do I call it? Middle. 165. 165 in lower. But after, you look and see if you put them. Okay, 6 plus 14, 20 plus 15, 35. 6 plus 7, it gives you 13 plus 22, 35. Now, when you want to now see, okay, what has actually changed? Actually, when you finish the analysis, you'll be able to know whether is there any change in their socioeconomic status. So, is the change we are looking at now across the different levels. So now, we have already known what we have on this observed table or observed value. How do we calculate the expected value? That's the next thing. And that is the same thing we did in McNemar. And it's the same principle. Now, you will see, if you remember, if you calculate, okay, how do you calculate? If you remember the way we calculated expected value, we said that expected value is the value when no hypothesis is true. What it means that, let's consider the first one now, the first pair, 7 and 14, between upper and middle. How many change from upper to middle? And how many change from middle to upper? Now, those are the change. If no hypothesis were to be true, what should be the expected value in each of them? You remember what you did is for you to add 7 and 40 together and divide by 2. That's what we did there. 7 plus 40 plus 7 divided by 2. So all the expected value, because no hypothesis say that there's no difference. That is, he's saying that the number that changed from upper to middle is the same thing that changed from middle to upper. That's what it means. It will be the same figure. So that's why you add the two together and divide by 2. Each of them 10.5, 10.5. The same thing is applicable to the green, the change between upper and lower. So you see, 15 plus 22 divided by 2 give you 18.5, 18.5. The same thing between middle and lower. Is it yes, middle, yes, middle and lower. So 50, 57. When you add them together, divide by 2, give you 53.5. So just like the way you can add McNemar-Bowker Chi-square, is all the, you just, you don't consider this concordance 6, 36, 93. You just say chi-square is equal to sigma observed minus expected square over expected. For each of them, you just put them. If you look at it now, there are 6. 1, 2, 3, 4, 5, 6. You add it, it gives you a chi-square, 4.116. The degree of freedom is, I have said to you before, it's the same thing with McNemar. The degree of freedom is k into k minus 1 divided by 2. So 3, because there are 3 categories, 3 into 3 minus 1 divided by 2 give you 3. The degree of freedom is 3. So chi-square value for the degree of freedom, critical value for degree of freedom 3 is 7.815. So if you look at it now, the calculated value is not as even high as up to 7.815. So the corresponding p-value will be far, far greater than 0.05. Show that it's not significant. Because the chi-square we got is not up to the value for the critical value of that degree of freedom 3. Now, that's that. If you remember, the short way of calculating McNemar, you don't even need to bother yourself about degree of freedom, what do I call it? The calculating the expected value. Can you see? All you need to do, the discordant, the difference between the discordant, square it, divided by the addition of the discordant. For example, now, for this cell, the red, what is the difference between 14 and 17? 14 minus 17, look at it here. 14 minus 17, look at it on the lower right. 14 minus 17 square over 14 plus 17. Plus, you did it for the other pair. 15 minus 22 square over 50 plus 22. Then plus 57 minus 50 square over 57 plus 50. So here you don't even bother yourself which one, like for example, now 50 plus 22. You don't bother yourself about the which one. Do you start with bigger or smaller one? Because since you are squaring, negative will cancel negative. So eventually, it gives you the same value we have just calculated. Can you see? So it's a short form of calculating it. And you'll be surprised if you, by the time we use the what do I call it? The machine expected to calculate it. It's not like McNemar. It will give you the figure. It's McNemar that it cannot give you the figure. No statistical software has given the figure. But for this one to give it. So let somebody share so that, or before that, or any question, before we now run it. Any question? Any question? I can see that I don't know what's wrong with today. Today, only 6 of you are around. If I'm right, only 6. And it appears that those people that I will not share that are around. So I don't know who is sharing now. I'll call your name. Okay, Samira, I share. You're going to share the same socioeconomic status or class. That one we used yesterday on Friday. We use for Pearson chi-square and chi-square for trend, socioeconomic class or socioeconomic status. So is the file, the SPSS file, socioeconomic status. Who will share, please? Samira.
Yes, sir. Sir, I'm not on with my computer. Someone should kindly share, please.
Okay, Onoja, share. At least your computer is working now.
I'm not with my computer.
Okay. Amanda, I've not even seen you before. I don't know if you are with you. It's not phone you are using now. Amanda. You see? Some people are going out now because of this sharing issue. So I can see the class is reducing. Nobody else. Okay. Dimas, Dr. Dimas. Dr. Dimas. I can't hear you. Are you talking? Are you talking? Am I muted? I'm not muted. Is it my microphone? I'm not hearing anything. My microphone is. Okay, Dr. Gazama. Will you share?
Good evening, sir. Sir, the speaker of my laptop got spoiled. It's not working.
So you're not hearing me?
No, sir. I'm using my phone now to listen to you.
Okay.
Yes,
So,
sir.
Dr. Dimas, you are not answering me. Okay. Anyway, people are not even many today. We just run this one and leave. So I'm forced to share. If I decide not to share, then nothing will happen. I don't know why. And this
Sir,
is
pardon us.
this is 3 weeks work, and we are just finished 1 week. People are tired.
No, sir, we are not tired.
No, sir. I'm saying you pardon us, not that we are tired, sir. Like, with respect to the sharing, sir.
Okay, no problem. I'm looking for this. So let me share because I didn't even open it. I know that socioeconomic class, yes. Yes. Let me share my own. Hope is the right one I'm sharing. Yes. No. No, it's not the right. I have to close this. Yeah, let me share. Yes. So this is the data set. You see, we have socioeconomic class before and after COVID. See the column. So it's very simple. Very simple. You just go to analyze. Analyze. Hope you can see. You now descriptive statistics. Cross tab. So the before, socioeconomic class before will be row. You know, it's the one that will serve as row. Row before column. Then socioeconomic class after will serve as column. Now we don't need all this as statistics. You see, that same McNemar you put to just McNemar. But of course, it will be McNemar-Bowker, you see it will bring out. Sorry, because I have to scroll. You know, okay. Can you see? Can see the output now. Socioeconomic class before COVID and socioeconomic class after COVID. You will see the same value you see in what we did before. See the same value. You see McNemar-Bowker, can you see? 4.116, that's what we calculated. And the degree of freedom is 3. And the p-value is 0.249. We already know that it will not be significant because the critical value for degree of freedom 3 is 7 point something. So anything 4.1, the p-value will be far above 0.05. Simple. So it's not a big deal. Yeah, the only thing is that the way you arrange the result, maybe that's the only thing I would now. The interpretation of the result, the way you arrange the result, you see that I don't bother myself. If you remember, when we ran the McNemar, I didn't bother myself about even the percentage, unlike the other one, when we did for employment status for male and female. We put the percentage, what percentage of women are employed, male are employed. All those percentages, because in your tabulation, you put it. So here, the percentage you may put will be the total percentage, not the percentage within the cell. So exactly the way this one is, the way you just put it like that, that's where you put it. So people will know, no, upper, 6, middle, 36, lower, 93. Those are the things. See, those some people, they just arrange the result like the way they do independence of the no, it doesn't make sense. You have to arrange it like this so that people will know, okay, what are the changes that occur, and see if these changes are statistically significant. So I think that's the end of McNemar-Bowker. Any question? Any question? So no question. You know, the problem number one, well, this session was very short. And I was even thinking also, we were able to move fast the last time. I was thinking that this one, if we finish this one, maybe we start discussing the t-test. But the problem we have now, only 5 of you are in this class. So we are finished with chi-square. So tomorrow we discuss t-test. Next tomorrow, non-parametric counterpart of t-test. You know t-test, there are 3 of them. We're looking at one sample t-test, independent sample t-test, and paired t-test. Those are the 3. So by next tomorrow, we'll discuss the non-parametric counterpart of these 3. And some other tests also that are non-parametric that we're going to do. Then the next that's on Wednesday. On Thursday, we discuss ANOVA. On Friday, we call measure of association, a relative risk, allowed to run the relative risk ratio. So any question? If there's no question, we'll just stop. I will share the video link with you. Good night, everyone. Since today is a day of being quiet.
Thank you, sir.
Good
You,
night.
sir. Good night.
Good
Thank
night.
you, sir.
Good night. Thank you.